ground fault circuit interrupter, or GFCI, is indeed required for outdoor de-icing equipment, irrespective of whether it is connected to a dedicated circuit. The primary reason for this requirement stems from the elevated risk of electrical shock associated with the use of electrical equipment in wet or damp outdoor environments. De-icing equipment, by its very nature, is employed in conditions where exposure to moisture is highly probable. This creates a pathway for electricity to leak or stray from its intended circuit, resulting in a ground fault. A ground fault occurs when electrical current deviates from its intended path and instead flows through an unintended conductor, such as a person or a damp surface. This can happen due to damaged insulation, faulty wiring, or even the accumulation of moisture within the equipment. The consequences of a ground fault can be severe, potentially leading to electrical shock, burns, or even electrocution. A GFCI is a specialized electrical safety device designed to detect even-minute imbalances in the electrical current flowing through a circuit. It constantly monitors the current flowing to and from the equipment. If it detects a difference of as little as 5 milliamps, 5 amps between the outgoing and incoming current, it interprets this as a ground fault. In response to this detection, the GFCI instantly trips, interrupting the flow of electricity to the circuit in a fraction of a second, typically within 20 to 30 milliseconds. This rapid interruption of power significantly reduces the duration of the electrical shock, minimizing the potential for serious injury. While a dedicated circuit provides a separate and isolated electrical pathway for the de-icing equipment, it does not eliminate the risk of ground faults. Even with a dedicated circuit, factors such as damaged cords, faulty equipment components, or water ingress can still lead to current leakage and ground faults. Therefore, the installation of a GFCI remains a crucial safety measure, regardless of whether the de-icing equipment is connected to a dedicated circuit or not. GFCIs are designed to protect people from the hazards of electrical shock and electrocution. They work by monitoring the flow of electricity in a circuit. When a ground fault occurs, the GFCI trips the circuit, cutting off the flow of electricity and preventing a potentially fatal shock. There are two main types of GFCIs: receptacle type GFCIs and circuit breaker type GFCIs. Receptacle type GFCIs are installed in place of standard electrical outlets. They have a test button and a reset button on the front. Circuit breaker type GFCIs are installed in the electrical panel. They protect the entire circuit that they are installed on. When choosing a GFCI for de-icing equipment, it is important to select one that is rated for outdoor use. Outdoor GFCIs are designed to withstand the elements and are less likely to be damaged by moisture or corrosion. It is also important to select a GFCI that is rated for the amperage of the circuit that it will be installed on. The amperage rating of the GFCI should be equal to or greater than the amperage rating of the circuit breaker that protects the circuit. To install a receptacle type GFCI, first turn off the power to the circuit at the electrical panel. Remove the old outlet and disconnect the wires. Connect the wires to the new GFCI receptacle, making sure to connect the wires to the correct terminals. The terminals are marked with the words line and load. The line wires are the wires that come from the electrical panel. The load wires are the wires that go to the next outlet in the circuit. Once the wires are connected, screw the GFCI receptacle into the electrical box and turn the power back on at the electrical panel. To install a circuit breaker type GFCI, first turn off the power to the circuit at the electrical panel. Remove the old circuit breaker and disconnect the wires. Connect the wires to the new GFCI circuit breaker, making sure to connect the wires to the correct terminals. The terminals are marked with the words line and load. The line wires are the wires that come from the electrical panel. The load wires are the wires that go to the next outlet in the circuit. Once the wires are connected, snap the GFCI circuit breaker into the electrical panel and turn the power back on at the electrical panel. Once the GFCI is installed, it is important to test it regularly to make sure that it is working properly. To test a receptacle type GFCI, press the test button. The GFCI should trip and the power to the outlet should be cut off. To reset the GFCI, press the reset button. To test a circuit breaker type GFCI, press the test button on the circuit breaker. The circuit breaker should trip and the power to the circuit should be cut off. To reset the circuit breaker, move the handle to the off position and then back to the on position. If the GFCI does not trip when the test button is pressed, or if it trips for no reason, it should be replaced immediately. GFCIs are an important safety device that can help to protect people from electrical shock and electrocution. They should be installed in all areas where there is a risk of exposure to moisture, such as bathrooms, kitchens, and outdoor areas. Regular testing of GFCIs is essential to ensure that they are working properly. GFCI protection is crucial for outdoor de-icing equipment to prevent electrical shock in wet conditions. Even with dedicated circuits, ground faults can occur due to damaged cords or faulty equipment. GFCIs detect small current imbalances and quickly cut off power, minimizing injury risk. Choose outdoor-rated GFCIs matching the circuit's amperage. Test regularly to ensure proper function and replace if needed. First, understand the purpose of a GFCI. Secondly, recognize the risks associated with de-icing equipment in wet environments. Thirdly, learn how GFCIs work to detect ground faults. Fourthly, choose the right type of GFCI for outdoor use. Fifthly, install the GFCI correctly, following all safety precautions. Sixthly, test the GFCI regularly to ensure proper function. Seventhly, replace the GFCI if it fails to operate correctly. Ground fault circuit interrupters are designed to protect individuals from electrical shock by monitoring the current flow in a circuit and quickly interrupting the power supply when a ground fault is detected. De-icing equipment used outdoors is inherently exposed to moisture, which significantly increases the risk of electrical shock. A ground fault can occur when electrical current strays from its intended path and flows through an unintended conductor, such as a person or a damp surface. GFCIs are designed to detect even small imbalances in the electrical current, as little as 5 mA, 5 amps, and quickly trip the circuit, cutting off the power supply to prevent electrical shock. Dedicated circuits provide a separate and isolated electrical pathway, but they do not eliminate the risk of ground faults caused by factors such as damaged cords, faulty equipment, or water ingress. There are two main types of GFCIs, receptacle type and circuit breaker type, each designed for different installation methods and protection scopes. Receptacle type GFCIs are installed in place of standard electrical outlets, offering localized protection at the point of use. Circuit breaker type GFCIs are installed in the electrical panel, providing protection for the entire circuit. Select a GFCI specifically rated for outdoor use to withstand the elements and ensure reliable operation. The amperage rating of the GFCI should match or exceed the amperage rating of the circuit breaker, protecting the circuit to ensure proper protection. Installing a GFCI involves connecting the line wires from the electrical panel and the load wires to the next outlet in the circuit, ensuring proper connections for safe and effective operation. Regular testing of the GFCI using the test and reset buttons is crucial to verify its functionality and ensure it is ready to protect against ground faults. If the GFCI fails to trip when the test button is pressed or trips for no apparent reason, it should be replaced immediately to maintain electrical safety. GFCIs are essential safety devices in areas with potential moisture exposure, such as bathrooms, kitchens, and outdoor locations, to minimize the risk of electrical shock. Adhering to electrical codes and safety guidelines, including the use of GFCIs, is paramount for ensuring the safety of individuals and preventing electrical accidents. Consider the specific environment where the de-icing equipment is used and choose a GFCI that is suitable for those conditions, such as one with a weatherproof enclosure. Ensure that all electrical connections are properly insulated and protected from moisture to prevent ground faults and maintain electrical safety. If you are unsure about any aspect of GFCI installation or electrical safety, consult with a qualified electrician for professional guidance and assistance. Properly installed and maintained GFCIs play a crucial role in safeguarding against electrical hazards and creating a safer environment for using electrical equipment outdoors. The National Electrical Code, or NEC, mandates GFCI protection in various locations and applications to enhance electrical safety and reduce the risk of electrical shock. First, determine the appropriate type of GFCI for the specific installation, considering factors such as location, equipment, and circuit requirements. Secondly, follow the manufacturer's instructions and all applicable electrical codes when installing the GFCI to ensure proper functionality and safety. Thirdly, regularly inspect the GFCI for any signs of damage or wear and tear, and replace it if necessary to maintain its effectiveness. Fourthly, educate users about the importance of GFCI protection and how to test and reset the device to promote electrical safety awareness. Fifthly, consult with a qualified electrician for any complex or challenging GFCI installations or troubleshooting to ensure compliance and safety. Sixthly, consider using GFCI protected extension cords when using de-icing equipment in areas without GFCI protected outlets for added safety. Seventhly, implement a regular maintenance schedule for all electrical equipment and wiring to prevent faults and ensure reliable operation. Understanding the principles of electrical safety and the role of GFCIs is essential for creating a safe and protected environment for using electrical equipment in potentially hazardous conditions.